If you have a numerical outcome variable in your research and you want to use a parametric test to analyze your data, then as a requirement, you have to first check whether your data is normally distributed. In this video, I'm going to show you 3 simple ways how you can check normality of your data. Here is the data set that we are going to use. You can download it from the link in the description of this video. We have got here 2 variables, height and weight, which are numeric. If you want to use any of these variables as your outcome for a parametric test, then you have to check whether it is normally distributed. And there are 3 simple ways to do this. One of them is to crudely compare the mean and median. If your data is normally distributed, then the mean should be equal to the median. So to obtain the mean and median, simply go to Statistics, Summaries, Tables and Tests, then Summaries and Descriptive Statistics, then Summary Statistics. In this dialog box, you specify which variables do you want. You can just select height and also weight. Otherwise, you would leave it empty if you want for all variables. Then under options, I want to choose this one for display additional statistics. Then click OK. From this output, we can see the descriptive statistics for these numerical variables. But of interest for us is the mean, which is 48.9, and the median, in this case the 50th percentile, which is 48.7. When you look at these 2 values, 48.7 and 48.9, these are close to each other, giving you an impression that maybe this variable is normally distributed because the values are close to each other. We can also look at weight, where we see that the mean is 28.1 and the median is 21.2. Compared to the first variable height, this one clearly, these values are not the same, giving us an impression that maybe this variable weight is not normally distributed. So that's the first one. The second way we can test for whether our data is normally distributed is to use graphical approaches or visualization using a histogram. And to do this, simply go to Graphics and then select Histogram. And then in this dialog box, we are going to specify which variable specifically. We want height first. If the data has got decimal points, select data is continuous. And if it is a whole number, then your data is discrete. Under density plots, I want you to add normal density plot and then click OK. So Stata has produced for us a histogram and then superimposed a normal curve to show you how normally distributed data would look like. And a bell shape indicates that our data is normally or roughly normally distributed. We could still do the same thing for our second variable, still graphics, histogram, and then instead here we choose to weight, then click OK. From this graph, clearly you can see that our data is not normally distributed. Our data is skewed to the right. So using the comparison of mean and median, we can tell that height is normally distributed, but weight seems not to be normally distributed. The third option for testing for normality is using a statistical test. There are several statistical tests, but here I'm going to demonstrate using the Shapiro-Wilk test. To run this test, simply go to Statistics, Summaries, Tables and Tests, then go to Distributional Plots and Tests, and then you select the Shapiro-Wilk normality test. In this dialog box, we are going to specify the variable we want, in this case height, and then we click Submit. Here is our output. Before we interpret it, we need to remember the hypothesis being tested by this Shapiro-Wilk test. It is testing the hypothesis that this data is normally distributed. So we are interested in a non-significant p-value for us to fail to reject that null. If we look at our p-value here, it is above 0.05, indicating that we fail to reject the null that our data is normally distributed. Therefore, weight as a variable has passed the normality assumption. We can run the same test again for the second variable height, and we see. Still, we shall go to statistics, summaries, distributional plots and tests. Then we go to Shapiro-Wilk normality test, and then we change, instead of height, we change it to weight. Then we click OK. Yeah, we put in those two variables at once. You can do the same. We see that for weight, this time round, it is statistically significant. The p-value is less than 0.05, indicating that we reject the null hypothesis, which tells us that data is normally distributed. So for this case, weight as a variable is not normally distributed. So you cannot use a parametric test, otherwise you will come to wrong conclusions. So depending on which type of test you want to do, you can explore transformation options for your variable to see whether after transformation it can be normally distributed, or else if everything fails, you can try out the non-parametric tests because they do not require your data to be normally distributed. So as a bonus tip, usually you can't rely on only one method of testing for normality. You can use a combination of methods. We also have other methods like skewness and kurtosis, especially if you have very large sample sizes of above 2000. So that's how to test for normality. If you found this video useful, consider liking, subscribing, and commenting to the video so that you don't miss out any of our future episodes. So next we are going to look at the independent samples to test in Stata. See you in the next video.